Okay, this video lesson is about solving right triangles. For the bell work, number one, set up the 6 basic trigonometric functions for the given triangle using angle A. Okay, again, we need to find the third side of this triangle. We're going to identify this as angle A. This is angle C. This is angle B. To find the third side, we're going to have to do Pythagorean theorem. So we have a squared plus b squared equals c squared. But b, remember, is opposite angle b, so that is 11. So plus 11 squared equals c squared, which is the hypotenuse, or the side opposite of angle c, which is always the right angle. Okay, when we square 11, we get 121. We square 20, we get 400. Subtract 121 on both sides. We get a squared equals 279. You then take the square root of both sides, and again, we're looking to see if we have a perfect square. 279 is not a perfect square, however, it can be simplified. So the square root of 279 can be simplified into the square root of 9 times 31, which becomes 3 because the square root of 9 is 3 times the square root of 31. So the value of a here is 3 square root 31. From there, then you set up your 6 ratios, again starting with the original 3, sine, cosine, tangent. This is where, again, I suggest always writing SOHCAHTOA, S-O-H-C-A-H-T-O-A, okay, because again, that tells you and identifies what the ratios are supposed to be for these trig functions. So sine of angle A is equal to the opposite divided by the hypotenuse. Which, if we go back to our triangle here and label things, if we're using angle A, this side across from it, or opposite of it, is my opposite. The one across from the right angle is always my hypotenuse. Then that would make this my adjacent. Okay, so we plug into the opposite. The opposite is 3 square root of 31, so 3 square root of 31 over the hypotenuse, which is 20. Since 3 and 20 are not simplifiable, we cannot reduce. Since the square root of 31 is on top, we also don't have to reduce. So my answer for sine of A is 3 square root of 31 divided by 20. Moving on to cosine. Cosine of A is the adjacent divided by the hypotenuse. Here the adjacent is 11. The hypotenuse is 20. Again, now looking at this, can we reduce? 11 over 20 is not simplifiable. It's already in reduced form. So 11 over 20 is my correct answer. Moving down the tangent of A is the opposite over the adjacent. Opposite again is 3 square root of 31, so we have 3 square root of 31 divided by the adjacent, which is the 11. Okay, again, that square root is not in the denominator, so we don't have to worry about multiplying by the square roots. And the 3 over 11 is already in simplest form, so that would be the answer for tangent of A. Okay, taking those then, we have to find then the reciprocal functions. The reciprocal functions, again, are cosecant, secant, and cotangent. All right, so here cosecant, or CSC, of angle A What we'd do before would we would backtrack through the work here and then find which one we can flip without having that square root on the bottom. The problem here is that we only have the one fraction. So you have to flip that. Okay, so I have 20 over 3 root 31. Again, we can't simplify that 3 into 20, so I have to go ahead and multiply by the square root of 31 to get rid of that and rationalize. So times the square root of 31 times the square root of 31. And that's going to give me 20 square root of 31 divided by, this is going to be 3 times 31. So 3 times 31. Which will be 20 square root of 31 divided by 93. Okay, secant, SEC of A. Again, we just take that and we flip it. Here we don't have a square root, so 20 over 11 is my answer. Cotangent, sixth and final one. Similar to cosecant up there, we have to take this and then flip it. Again, we don't have anything else ahead of that we can simplify and flip and make life a little bit easier. So we take this and we turn it around. We have 11 over 3 square root of 31. Again, I have that square root in the denominator, so I need to get rid of that and rationalize. So we multiply by the square root of 31, by the square root of 31, which gives me 11 root 31 over, and again we have a similar situation on the bottom, 3 times 31, which we can then multiply, so we have 11 root 31 divided by 93. Question number 2 then, how many degrees is in the sum of all 3 angles inside of a triangle? So all the internal angles, okay, or the interior angles of the triangle add up to 180 degrees. Again, we know that by the triangle sum theorem that we learned about in Unit 4 when talking about proofs. Okay, moving on to the content of the problems here. We are again talking about solving right triangles. We're going to do right triangles right now, and then we will do non-right triangles in the next couple of sections. Okay, but to solve a triangle in general, you are going to be given information, and I'm going to give you one of two things. I could either give you a measure of one side and one angle, or I can give you the measure of 2 sides. Okay. In all actuality, I'm giving you 3 things in these problems because I've already told you that we are solving right triangles. So number 1 up top there, I'm actually going to give you 1 side and 2 angles because I'm giving you the right angle. Okay. Number 2, I'm giving you 2 sides and again the right angle. So you have 3 pieces of information. You are going to want to find all 3 sides and all 3 angles. So what I do not give you, you will have to find. Okay? In the situation where I give you 1 side and 1 angle, number 1 says to find the 3rd angle first. Again, this is just a suggestion. You can do so by taking 90 minus the given angle And I only say 90 minus the given angle because we have 3 angles. And again, I have one that is given to me as a right angle. It is already 90 degrees. So really I'm taking 180 minus that 90 that I already have, and then minus the other angle that I'm given. So we have 90 minus the given angle is that third angle that we're missing. Okay, second thing there, and I'm actually going to teach you to just use the SOHCAHTOA stuff, and we're going to set up all 3 ratios, and I'm going to have you just solve 2 of the ratios. Okay, you can use Pythagorean theorem after you find one of them, but it's just going to be a little bit easier to just go ahead and continue with the usage of the trig functions. Okay, so I'm going to zoom out a little bit to give myself a little bit more room. Okay, so I'm going to identify the things that were given here and label the triangle. Again, you do not have to label the triangle. You can only do it if you feel free to. Okay, so I'm going to do it in 2 different colors to identify what we have and what we don't have and what we need. Okay, so we have angle A at 65 degrees. We also know angle C is my right angle. We don't know angle B, as I'm trying to write an A. We do not know side A, which is opposite of angle A. And we don't know side C, which is opposite of angle C. Okay, so side B is over here. Okay, so again, you are given 3 pieces of information. You are given angle A, you are given side B, and we know angle C because, again, angle C is always that right angle. So we are identifying or trying to solve the triangle, and in order to solve the triangle, we have to find the 3 missing components, which here are in red. We are missing side A, we are missing side C, and we are missing angle B. Okay. My first suggestion would be to go ahead and solve for angle B, because again, it's not that difficult. Angle B is equal to the 180 minus angle C, which is the 90 degrees, minus, and I want you to put angle A here so you can see it. Okay, so angle B is equal to the 90 minus angle A, which was given as 65 degrees. So angle B is equal to 90 minus 65, which is 25 degrees. Okay. Continuing then, you're going to set up the 3 ratios. You're going to solve then for side A and side C. Okay, so again, we're using SOHCAHTOA. And when you set up sine, okay, we're going to use whatever angle you choose. So I'm going to use angle A because we've used it pretty frequently. So I'm going to again do this and identify my sides. So this is my opposite. This is my adjacent. This is my hypotenuse. Okay, when I identify sine of A, I'm going to use sine of 65 now because I have the value of angle A. Okay, we have opposite, which is the letter A. We don't know it yet. And then we are going to use the hypotenuse, again, letter C now, because we don't know it. Okay. You'll notice with 2 of these functions that you set up, you will be only missing 1 piece of the information. Here, I'm missing 2 pieces. I have letter A and I have lowercase letter C that I don't know. So I'm actually not going to be able to use sine in this example. Okay. In further examples, you will be able to use them. Setting up cosine, I have cosine of angle A again, 65 degrees, which is equal to the adjacent, which is the 17, divided by the hypotenuse, which we don't know. Okay. In order to solve this now, you have to get C by itself. So the question is, how do you do that? with any fraction, my suggestion is always to get rid of the denominator first. So in order to get rid of the denominator here, I need to multiply both sides by that denominator. So that's the c value. Okay, so c's here would cancel out, which would give me here then c times the cosine of 65, and that's going to equal the 17. Okay, the hard thing for a lot of people on this section in any of these things with the trig functions is that they try to simplify by solving and dividing both sides here by 65. It's important to note that cosine of 65 is a number. It is one solid number. Okay, so you have to divide both sides here by cosine of 65. Okay, when you do that, then your cosines here will cancel, leaving us just the c term. And then I'm going to simplify by plugging this into a calculator. The problem with doing this on something like this is that every calculator is different. They can all computate this, but the problem is, how do you plug it in? So you're going to have to reach out to me and ask for me how to plug it into your specific calculator. Okay, but if I take 17 divided by the cosine of 65, I'm going to get approximately, so I'm not going to do the equal sign, I'm going to do the little tildes. Okay, and that's about 40.23. Okay, again, you'll be able to plug that into a calculator. The question is, what calculator do you have, and how do you plug it in operations wise? Okay, so again, reach out to me and we'll try to figure that one out. Okay. From here then, again, I'm going to set up all three ratios. So I haven't set up tangent yet. So on the side here, I'm going to set up tangent. So tangent of, again, angle A, which is 65 degrees, is the opposite over the adjacent. So the opposite is side A over the adjacent, which was that 17 for side B. Okay, on this one, again, I'm going to do the same thing. I want to multiply both sides by that denominator so that we can eliminate the fraction. Okay, the nice thing with this is that when I multiply by the 17 now in the denominator, it go ahead and isolates the A, right? A is now by itself. So I have 17 times tangent of 65 is the value of A. Okay, so again, I'm going to work this side out in a calculator. It gives me about 36.46. And again, I'm going to use the little tilde equal sign, not just the regular equal sign, because these are approximations. These are rounded off, and this is not the holistic answer. Okay, but I do want to see two decimal values here. Okay, so again, we need to solve this triangle by solving for the three missing components. We need to find angle B, which we did here. We need to find side C, which we did here. And we need to find side A, which we did here. Okay, so now you're done with this problem. Again, this is a kind of problem where I give you one angle and one side. Okay, or again, two angles if I include angle C. Okay, moving on to the next. When I give you two sides, you're going to have to use something called the inverse functions. Okay, inverse functions, you will see the little exponent of -1 just above sine, cosine, and tangent. Okay, you're going to set up the ratios in the same way, but you cannot divide by sine itself. Okay, so you actually have to take the inverse sine of both sides. Okay, so if you look down below, finding the measure of the angle, you're going to set up the sides ratios, SOHCAHTOA, and then you're going to use sine, inverse sine of the opposite over the hypotenuse is equal to A, or the inverse cosine of the adjacent over the hypotenuse is equal to A, or the inverse tangent of the opposite over the adjacent is equal to A. again, you're going to round these off. I know it says the nearest 10th of a degree. However, let's round it off to 2 decimals. Let's go ahead and do it to the nearest 100th. Okay. Again, when you plug these into a calculator, depending on the calculator that you're using, the buttons that you hit and the sequence in which you hit them will be different. Okay, so you will have to reach out to me or find me in class to figure out how to operate your calculator specifically. Okay, going through the procedures again here. You're going to find the third side, so you're going to set up Pythagorean theorem, a squared plus b squared equals c squared, and find that third missing side. And then you're going to set up SOHCAHTOA. Okay, so similar to what we did for the last problem, set up the ratios. And then here you're going to have to use that inverse function. Okay, so my suggestion here is that I'm going to give you 2 nice sides. Okay, the third side that you use Pythagorean theorem to find may come out to a nice integer value, or it may not. Okay, if it comes out to be a square root that you can simplify, you can plug that in and use it. However, my suggestion is to use the functions setup that has the 2 side lengths that I gave you as integer values. Okay, you should come up with the same answer regardless of which one you use. However, when you plug this into a calculator, again, it makes it significantly easier to do. Okay, once we find that second angle other than the right angle, we can go down to the number 4 there and we can find the third angle. Here, my suggestion would be to take the 180 minus the 90 minus the one that you just found, okay, or just 90 minus the one that we just found. Okay, so again, I'll zoom out here to give myself plenty of space to figure this out and to show as much work as I can, especially since this is a video. Okay, so first thing first, again, my suggestion would be to label things. Okay, label what we are missing in one color and then what we have in another. I don't have angle A. Okay, again, I'm going to stay consistent and leave angle A at the top. I don't have angle B. And I don't have side B, which is opposite of angle B. Okay. However, I do have angle C, which is that right angle. I do have side A, which is 7. And I do have side C, which is the 15. Okay. Setting up Pythagorean theorem, we have a squared plus b squared equals c squared. So plugging in what we have, 7 squared plus b squared equals 15 squared, which is 49, plus b squared equals 225. And if we subtract 49 on both sides, that tells me that b squared is equal to 176. You then take the square root of both sides. Again, paying attention to the fact that square root of 176 is not a perfect square. However, it can be reduced. Okay, the square root of 176 can become the square root of 16 times 11. Again, using 16 because that is the largest perfect square that I have. Square root of 16 is 4, so it's 4 square root of 11. Okay, I do not want decimal values for these. I do want a simplified square root. Okay, because again, I like to keep them as holistic as possible. So the answer here is 4 square root of 11. Okay, moving on to the next thing. Again, my suggestion is to go through and label your sides. Okay, so you're gonna pick, do you want to use angle A or do you want to use angle B? Okay, my suggestion again, find one that you want to go with and stay consistent. Okay, set it up the same every single time because it doesn't matter if we use angle A or angle B. Okay, You choose. But I'm going to stay consistent. I'm going to use angle A. So if I use angle A, again, this is my opposite. This is my adjacent. And this is my hypotenuse. Okay? Set up the ratios. So again, we're using SOHCAHTOA. Okay? If we set up sine, and we need angle A, because I don't know angle A, I don't have a degree measurement for that yet, is equal to the opposite over the hypotenuse. So we have 7 over 15. Okay? Cosine of angle A is the adjacent divided by the hypotenuse. So the adjacent was 4 square root of 11 over 15. And then tangent of angle A is the opposite over the adjacent. So we have 7 over 4 square root of 11. Okay, again, looking at the three ratios that I have 2 of them that have side B, or the adjacent here, that are square roots. Okay, and again, depending on the type of calculator you're using, it makes it a little bit more difficult to plug them in. Okay, so for the purpose of this, my suggestion again is to use the 1, so sine here. It's not always going to be sine, okay, but sine for this problem has the 2 sides that I gave you, and they're nice integer values. Okay, so if you had that ABC feature on your calculator, you can just hit 7 ABC 15 and then give yourself a fraction to work with. Okay. From here, then we have to solve for angle A. Again, I need to take the inverse. I can't just divide by sine because that's a function. It's not a value, it's a function. So in order to do that, I have to take the inverse sine. And I'm going to, actually, let's do this. I'm going to rewrite this. So I'm going to take the inverse sine, possibly, inverse sine of the sine of A. And then what I do to one side of a fraction, one side of an equation, I'm going to do to the other side. So I have to do the inverse sine of this side as well. Okay, and we do that again because inverse sine here and sine there will cancel each other out. It's similar to the square root of a square. Those cancel. The inverse and the function itself will cancel each other. So this just becomes now A equals the inverse sine of that ratio. Okay, and again, depending on the calculator you're using, it will depend on how you plug this in. Okay? But if I take the inverse sine of 7 over 15, I end up with angle A being approximately 27.82 degrees. Okay, so far we've solved for 2 of the missing components. We were missing angle B, we were missing angle A, and we were missing side B. So we have now found side B and angle A. So the third thing that we need to find, and the last thing we need to find, is angle B. And to do that, we're just going to go back to the fact that in a triangle, we have 180 degrees. Okay, we're minusing the 90 degrees for that right angle, and then we're subtracting, again, angle A, and I'll just write it so that you can see it. Okay, so now angle B, and again, I'm going to change this from an equal sign to an approximate because we've rounded this off. So now it's not equal to it, it's approximately what it should be. So we have 90 here, minus the 27.82 degrees. Okay, and 90 because we have the 180 minus 90, which then means that angle B is approximately 62.18 degrees. Okay, so two types of problems that I'm going to present. One where I give you the side and one angle, or the second type is this where I give you two sides. Okay, if you have any questions, comments, or concerns, again, by all means, reach out to me and get a hold of me and ask away.